Ladies and gentlemen, we're going to be talking about gas density and molar mass, and this is out of chapter 10, section 5. So you might want to take a look at chapter 10, section 5, read through that as well, work some of those practice problems. But let's get going on some of the formulas that we're going to use, gas density and molar mass. So first off, we have four different formulas that have the potential for coming into play. One is just a basic density formula as density equals mass divided by volume that's used quite often. And for gases, this density is usually measured in grams for the mass and liters for the volume as our units. And that's important because oftentimes we're dealing with solids, we deal with grams per milliliter or grams per centimeters cubed. But here we're going to do grams per liters. We also have molar mass. And molar mass is the same molar mass that we've always talked about. And we're going to use the capital M for molar mass. And this is just going to be measured in grams per mole. We can also use our formula for the ideal gas law, PV equals nRT. And the importance there, of course, is the number of moles. It also, which we need for grams. It also is important because it has the volume component in there. And so if we know moles and we know volume, we can incorporate both of these or all three of these formulas together, and we're gonna come up with a new formula. And I'm not going to derive it here. You can look in your book to see how it was derived, but that's the formula for molar mass of a gas. So molar mass of a gas, using capital M there again, is going to be equal to the density of a gas multiplied by the ideal gas law constant, 0.0821, multiplied by the temperature in Kelvin, divided by pressure. And of course, this can also be solved for density as well. And so we could have density is equal to molar mass multiplied by pressure divided by ideal gas law constant multiplied by temperature. So these two are essentially the same formula. It just depends on which one we need to use to get to what we're after. So but we also might use that density formula up there. We might use the molar mass formula. It really depends, and you'll see that in the second example that we're about to talk about. And so I'm going to slide this up here, and this question is going to ask me what's the density of carbon tetrachloride at 714 torr and 125 degrees Celsius. So I'm going to try out just using this density formula. I mean, I cannot use density equals mass over volume because one, I don't know the mass of this gas, and two, I don't know the volume of this gas, so we're not going to be able to use that formula. But I think I can use density equals molar mass times pressure divided by ideal gas law constant times temperature, because that will work. So I'm just going to quickly calculate the molar mass of CCl4, 1 carbon plus 4 chlorines, and if I do that right, I believe that comes out to about 153.81 grams per mole. I'm going to multiply that by the pressure. Now I do have pressure given right here in torr, and I need it in atmospheres because I do have R here to deal with. So I'm going to do, we'll do 714 torr, and we're going to do a quick little conversion, 1 atm, 760 torr, just like that. And then on the bottom, ideal gas law constant, 0.0821 liters atm moles Kelvin, multiplied by temperature, 125. Remember, we always have to convert that to Kelvin because we have our Kelvin conversion there. So this is going to be 398 K. I'm going to double check some conversions to make sure units are going to cancel properly. So Kelvin cancels and Kelvin cancels there. I have moles there. I have moles there. I have torr canceling with torr. I have atmosphere canceling for the atmosphere. And so what I'm left with on my units is I'm left with a unit of, let's see where we're at here, I'm left with a unit of grams per liters, which is really what I want for gas density. Okay, so I'm going to do this calculation. Now I'm going to slide this up a little bit, do this calculation, and the calculation should come out and give me 4.43 grams per liter for my density of this gas at 714 torr and 125 degrees Celsius. Okay? So that was an easy, kind of a real, just a plug and chug type question, but let's take a look at what is more of an AP style question, and this is incorporating a whole bunch of different things into one question in multiple steps. So it's going to ask us to calculate the molar mass of an unknown gas if it's placed in an empty flask. So just starting off here, we're probably going to use our molar mass formula. Most likely molar mass is equal to density times R times T divided by pressure. Okay, so we'll see what we have here. The empty flask has a mass of 134.567 grams, so it's probably been evacuated, they like to say, which means they've pulled out all the air, and we're taking a mass of nothing but just the flask. After the gas is placed in the flask has a mass of 137.456. So right off the bat, we should be able to calculate. Let's calculate mass of the gas, and that's just going to be 137.456 grams minus 134.567 grams, and that's just going to give us, I believe it's 2.889 grams of gas. Okay, so now we know how much gas we have, and that's an important thing, because right here we need density, and this is one piece, because remember density is grams per liter, so that's one piece of our density problem there. Let's go ahead and find the volume. And so this of our flask. Now it says up here, I'm going to keep reading, to find the volume of the flask was filled with water and the mass was taken. Okay, so they filled it up with water, all right, and the mass of the flask and water was 1,067.9 grams, and then they give us a density problem, a density of water of 0.997 grams per milliliter. So we're going to do a couple things here. The first thing we're going to do is we're going to do mass of water. And so I'm just going to subtract 1067.9 grams minus the empty flask, which once again was 134.567 grams. And so I can get the mass of my water, and I believe that comes out to 933.3 grams of water. So that's an important thing for water. Then what I'm going to do is I'm going to use the density formula, density equals mass over volume. They gave me the density of water being 0.997 grams per milliliter, and I now know that the mass of the water is 933.3 grams. So I'm going to solve this equation for volume. Volume is equal to 933.3 grams divided by 0.997 grams per milliliter. And so when I divide those two, I come up with 936 milliliters, which is equal to 0.936 liters. Okay, so that's an important piece as well. So let's scroll down here a little bit. So the next thing we want to do here is we're going to find the density of our gas. Now, in this case, we're just going to use a straight density equals mass of the gas divided by the volume of the gas. Now, the mass of the gas we calculated up there in step 1 was 2.889 grams. The volume this guy is going to occupy, we just calculated that in step number 2, 0.936 liters. And so when we divide these two, we get 3.09 grams per liter. Okay? Now, that's an important piece because we're now going to use the formula. We're going to find the molar mass. The molar mass of the gas, we're going to use the formula molar mass equals density, which we just calculated, multiplied by the ideal gas law constant, multiplied by temperature, divided by pressure. So, density that we just calculated, 3.09 grams per liter, multiplied by the ideal gas law constant, 0.0821 liters atmosphere moles Kelvin, multiplied by temperature. In this case, temperature was given to us as 31 degrees Celsius, so I'm going to have to add 273 to that. So I get 304. And this is all going to be divided by pressure. And the original pressure in here was 735 torr. And 735 torr, of course, we have to convert to atmosphere. Just like that. Okay. And so once we do all these calculations and run this through our calculators, we should come up with an answer of about 79.7 grams per milliliter. Oh, I'm sorry, grams per mole for our density. I'm going to double check to make sure all my units calculate or convert right. So I've got Kelvin, torr, atmosphere, liters, grams. We look good. That's the end of the lecture for tonight, and then we will do some of the practice problems on all this good stuff tomorrow. Hope you guys have a nice evening.